Electricity has become one of the most essential parts of modern life, yet most people have very little understanding of how it is actually produced. We flip a switch and expect power to appear instantly. But behind that simple action is a complex system of generation, transmission, and distribution. Because electricity is so important, many homeowners have started asking a practical question: is there a way to produce some energy at home instead of relying entirely on the grid? This question has led to growing interest in small-scale energy solutions. One concept that often appears in online discussions is something called the energy revolution system. But what exactly is it, and how does it work? To understand that, we need to start with the problem many people are trying to solve. Energy costs have gradually increased in many parts of the world. At the same time, homes today rely on more electronic devices than ever before. Computers, smart appliances, lighting systems, chargers, and climate control units all contribute to rising electricity use. Even small increases in power consumption can affect monthly utility bills. Because of this, people naturally begin exploring alternatives. Some look into solar panels. Others research small wind turbines or battery storage systems. Another area of interest involves small generator systems based on basic electrical engineering principles. The energy revolution system is often discussed within this category. At its core, the system focuses on explaining how small-scale electricity generation works and how certain components can be combined to create a compact generator setup. The science behind this type of system is not new. In fact, it is based on one of the most important discoveries in the history of electricity: electromagnetic induction. This principle was discovered in the 1800s and is still the foundation of modern power generation. The idea is straightforward. When a magnetic field moves near a conductor, such as copper wire, it can cause electrons in that wire to start moving. That movement of electrons becomes electrical current. In large power plants, turbines spin massive generators. These turbines may be driven by steam, water, wind, or other energy sources. As the turbines rotate, they spin magnetic assemblies inside coils of wire. The changing magnetic fields create the electricity that eventually reaches homes and businesses. What makes the energy revolution system interesting is that it focuses on showing how the same principle can be demonstrated on a much smaller scale. Instead of massive turbines, a small experimental system may use a simple rotor that holds permanent magnets. Near that rotor sits a coil made from copper magnet wire. As the rotor spins, the magnets pass close to the coil. Each time a magnet moves past the wire, the magnetic field around the coil changes. This change forces electrons inside the wire to move, producing electrical current. In most small generator setups, the electricity produced is alternating current. That happens because the magnetic field changes direction as the magnets rotate. To make the electricity more useful for certain devices or battery charging systems, a small component called a rectifier can convert alternating current into direct current. From there, the electricity can be stored in a battery or used by low-power devices. The components used in these systems are relatively simple. Copper magnet wire forms the coil. Permanent magnets create the magnetic field. A rotating mechanism provides motion. Basic electronic parts manage or convert the electrical output. When these pieces are arranged correctly, they create a small generator capable of producing electricity whenever motion is applied. But it is important to understand something that is often misunderstood in discussions about generator systems. No generator creates energy from nothing. This is a fundamental rule of physics. Generators convert energy from one form into another. Mechanical motion becomes electrical current. If the rotor spins, electricity can be produced. But the spinning motion must come from somewhere. In practical setups, that motion might come from wind, flowing water, mechanical equipment, or even manual rotation. This is why most small-scale generators are used as supplemental systems rather than primary power sources. They can provide useful amounts of electricity for specific tasks, but they are not designed to replace large power infrastructure. Understanding this distinction is an important part of evaluating systems like the energy revolution system. The real value of these systems often lies in education and awareness. They help people see how electricity is actually produced. Magnets, coils, motion, and circuits stop being abstract ideas and become visible components interacting with each other. Once people understand these principles, electricity becomes much less mysterious. It becomes a process that can be observed, tested, and improved. This often leads to a broader interest in energy systems. People begin paying closer attention to how much power their devices consume. They start exploring ways to improve efficiency in their homes, some eventually expand their knowledge into areas like solar power, battery storage, or energy management systems. In that sense, small generator systems can serve as a starting point for a deeper understanding of how energy works. They reveal the structure behind something most people use every day but rarely think about. The key insight from reviewing the energy revolution system is that electricity generation follows clear physical rules. Magnets create magnetic fields, motion changes those fields, coils capture the resulting electrical current. When these elements work together, electricity appears. This same structure exists in everything from handheld generators to massive hydroelectric plants. The scale changes, but the physics remains the same. Learning these principles helps people see energy systems more clearly and make more informed decisions about how electricity is produced and used. The energy revolution system highlights those ideas by focusing on the building blocks of small-scale electricity generation. If you enjoy learning how practical energy systems work and how simple engineering concepts shape the technology we use every day, consider subscribing to the channel. New videos break down complex topics in clear and simple language. You can also check the description for a helpful resource that explains the basic components and structure often discussed when people explore systems like the energy revolution system and other small-scale generator projects.